Hello, hello. All right, I'm starting a new stream. I have reconfigured my setup, so let me just make sure everything's up and running right now. Give me 1 second, we're going to get right into it. I'm playing live. So what happened was the streaming software that I've been using, StreamYard, I have to pay because I've streamed nearly 20 hours. It's like 200 a year, I believe, give or take. But the thing about it is, if I was to do that, I've used OBS before when I was streaming skating stuff, so I just downloaded the latest one and reconfigured it for this. Let me see here. Yeah, it's not bad. I like what I'm seeing here. Okay, well, let's get right into it. All right, so the configuration, pretty happy with it. And let me just see here. There we go. Okay, so I'm just gonna let it run, and we are getting right into it. All right, this is gonna be 2.1. All right, we are in a new chapter. Isn't that exciting? 2.1. Logic. All right, the book is in the video description. Just go there, download it, get the book. It's a very nice book, and it is a Creative Commons book, and you could also buy it with the link, support the author and all that. I totally agree with that. I have a physical copy. It's a great book. Okay, so decide whether true or false. So they're gonna start it off a little easy, and then by the last chapter it'll be hard, just like that last stream was. So basically, -3 is part of the integer sets. So and the integer sets is part of the real sets. So if I said -3 is a member of the reals, then that's I said every real number. That's what they were asking me. And now we're gonna say, right, 3. We're gonna say, what am I writing today? Let me turn this a little bit toward me. If x and y are real, and 5x is equal to 5y, comma, then x is equal to y. All right, so if x are part of the real set, yes. Yes. X comma y are members of the real set such that 5x is equal to 5y. All right. And we're going to say 5x to 5y divided by 5, which is equal to 5. Sorry. X equal to y. So the only thing that I said there is and now I use such that I guess that's fine. It doesn't matter. I mean, it's slightly technically different than what they wrote there. This is like an if-else statement, so such that might not exactly be appropriate here for this kind of instance, but I was just writing it as a quick example. So don't take that statement too seriously. All right, and here we go. Let me see here. Yeah. Let's go look at the answers. Statement, yes, the book says it is false. And the statement is true. So far, so good. Again, they start us off easy, you know? They don't want us to be freaking out just yet. Okay, so if you've done logic before, then you can kind of skip reading this, but if you haven't, you absolutely need to start reading the book. Sets Z and N are finite. They're infinite. Yeah, N is not a finite set. It goes to infinity. And true. Let's see here. So the range of N is 1, infinity. Okay, and it can't be less than that. And the range of Zahlen integers is negative infinity to positive infinity. The square bracket means closed. The parenthesis means open. Infinities are unbounded because you can't say what's the last number in an infinite set. So even if you were to graph something in closed brackets, if you get to infinity, then that means it's an open bracket thing. So yeah. So like anyway, let's see how we did there. Statement true. Yes, book agrees. Again, this is this is very straightforward stuff that we're doing right now. Okay, the derivative. Okay. A minute here. Cancel. So so we want to take the derivative of, so we're going to say x, the derivative of a polynomial of degree 5, x to the 5th power, and we take the derivative of that would be, should be x6 to the 6th. Is that right? I think that's true. It's a polynomial of degree 6. Where's that? This is what I got to incorporate calculus. My derivatives and integrals, you keep mixing them up. That's the only thing. Do I need... The derivative should go there. Okay. Let me just remember the integration. If I were to... Because these are they're part of the fundamental theorem of calculus. Let's see here. So basically, derivative and the integral, they are like addition and subtraction. Think of it that way. If I wanted to, I think that's integration. If I take 3 and integrated, that's the thing. I got Jesus. Whatever. I'm just gonna check my answer here. Oh, false. Okay, so I mixed it up. Yeah, I did an integration there. What I did was I did so this is false. So the derivative would be and actually I didn't do that correct. Oh god. I'm so adding calculus next to the books I have to do. It's going to be 4x over the 4. I think that's the correct way to if I was to take the derivative of that. I think that's it. Hang on. All right. Let me see here if I can do it here. Okay, so one site that you can do is Mathway, which, if you wanted to check it real quick, I'm not gonna throw this thing off real quick. I'm just gonna go check that real quick. Let's see here. Integral of x to the 5th power. So that I did an integration. So so an integration was like this. If you take the integral of x to the 5th power, derivative of x, so then that becomes like this. So it becomes 1/6, and then it's going to be x to the 6th power plus c. What happens is, so if we wanted to, so the answer for our what was the question here? But that was, let's see here, 7. The derivative of any polynomial of degree 5. Okay, so taking the derivative, so an integral adds a number, a derivative subtracts a number. So that should be, let me see here. It would be, yeah, definitely adding calculus to the list of things I'm going to be doing here. Okay, so right, so if it was x to the 5th power, the derivative would actually do this. It would subtract this, and we would carry this over this way. Okay, yeah. Okay, that's good. Anyway, let's not get caught up on that. The answer was that is false. Okay, next, like I said, I'll add calculus to the list. So coming up, I'm going to be doing linear algebra calculus on top of what I'm doing here with this book of proof. That's proofs. And also I do algebra and trigonometry. And eventually I'm going to add calculus 2. Actually, yeah, I'm going to start calculus 1, but I'll be doing 2 and 3 as well. So I'm going to be doing like 6 books. Oh, this is going to be hard, but hey, I'm doing this to get better at math. All right, so these are statements. We just need to know true or false. Cosine x is equal to -1. Is this a true statement? Let's see here. So cos x, well, it depends upon what the theta is. It can be -1. When the cosine is at let me see here. It's pi over. I mean, I guess this is not a false statement, I would say. So it's a true statement. So I'm going to say. Right. Oh, okay. It's not a statement. When I said it's not a. I mean, when I said it's not a wrong statement, it's not a statement to begin with. So that's a tricky thing they threw at us. So it's not just binary. It's not just true and false. You could have a non-statement. It's just like saying the letter A. Well, the letter A what? You know, it's just the letter A. It doesn't. It's not true or false. It's simply a statement. but not one that you can falsify or make true. All right. 11. The integer x is a multiple of 7. Okay. The integer x is a multiple of 7. Not a statement. This is not something that I can falsify. Because, okay, if the integer of x... Okay, 11. Okay. I'm going to say... I'm just going to write this. X is a member of the integers. And comma x is x I'm gonna here. We can go x divisible by 7. I don't know, hang on a minute. Oh, just write it out. Not a statement. So when we say it's not a statement, we mean it's an open sentence. Basically, if we say that the integer x is a multiple of 7, it's not falsifiable, so it's an open sentence, but not a statement. A statement is something that we can falsify. So it's binary, it's true or false. All right, good. 13. Either x is a multiple of 7 or it is not. True. Simply falsifiable. Although, hang on a minute. No, actually, hold on. Either x... I need to learn to spell. I need to finish my words. Either x is a 7... Okay, it's an open sentence. Okay. Can't falsify it. I mean, it's saying that it's one or the other, but that tells us nothing. We can't... I suppose the statement... Hold on a minute. Hold on. Well, hold on. It's true in the sense that it either will be a multiple of 7 or it is not. I guess we don't have to falsify it. When we say true or false, it's a little more complicated than that. It's simply if we can... Here we go. I would say it's true because it has no inherent contradictions. Let's put it that way. It's internally consistent. That's right. This is a statement for the sentence is true no matter what x is. So this is a statement, so we have to decide if it's a statement. Essentially, a statement is something that has a value of truth or falseness to it. And in this case, yeah, that's what it is. All right, that's good. So a statement, false, and then not a statement, not a statement. Okay. There we go. So first thing, we have to establish if it's a statement or not. A statement is something that has a truth value. It could be true, it could be false. And then we have to decide on the truth value. Otherwise, it's not if it's not a statement, then it's an open sentence. Of course, we could have a false statement, but that's then it's false. Okay, so oh, that's cool. See, whoever wrote this book has got some good taste. Number 14 is Call Me Ishmael, right? Now, if they put that in there, that's good taste. And if you don't know where that's from, that's Moby Dick. And I have it here. So we are currently on page 38. Let me find Moby Dick. Hang on a minute. Let's see here. All right, hang on a minute. Moby Dick, right here. So I got my desk right in front of my 4 bookcases here. And since Melville is M, it happens to be on one shelf above it. So Call Me Ishmael. Some years ago, never mind how long precisely, how little or no money in my purse, and nothing particular to interest me on the shore, I thought I would sail about a little and see the watery part of the world. Yeah. All right. Well, 15. Let's get to 15. Anyway. In the beginning, God created the heaven and the earth. That would say that's a sentence. Oh, hold on a minute. No, that's a statement because God either did do it or did not do it. I guess whether or not he did it, it kind of depends upon your personal religious beliefs. But for the sake of the argument of this, in the beginning, God created the heaven and the earth, which is Genesis 1:1. So let's see here. We want to say, I guess we would have to call this a true statement. I mean, you could say, all right, 15. Now, I'm not a religious person, but I'm more interested in this. How do we handle a statement like that? And I would say it has a truth value. Okay, that's my take on that. It's clearly a statement because there's an action being taken, and that can be proven or disproven. Now, at least theoretically, in the sense that if you're doing this in math, again, math is not religious studies, but if it was like religious studies, then it has a truth value. Or some people would say it's self-evident. So yeah, I would give it the truth statement. A statement, and that is true. Let's go to 15. All right. This is a statement for it to either be definitely true or definitely false. For it is either definitely true or definitely false. There is some controversy over whether it's true or false, but no one claims there is neither true nor false. Okay. So that's good. All right. Yeah, we got through that chapter, and that was 2.1. And I hope you enjoyed this fun and exciting turn that we have toward true values in Chapter 2. And now, let me take a look at Chapter 2.2. Okay. All right. Yeah, let's do 2.2 as well. I'm going to stop this stream. And then I'm going to restart it. I go by chapters. Or sections.